Welcome to our exploration of user administration and disk management. System administration encompasses a wide range of tasks, but few are as crucial as these. These disciplines ensure that the system's resources are correctly allocated and safeguarded, impacting everything from user accessibility to security. Understanding these areas is essential for anyone tasked with managing IT infrastructure. User administration involves managing user access to system resources, including creating and maintaining user profiles, assigning permissions, and monitoring user activities. On the other hand, disk management focuses on the optimization and allocation of disk space. This includes managing partitions, file systems, and ensuring data integrity through various storage management techniques. Together, these disciplines form the backbone of effective system administration, enhancing both system performance and security. For system administrators, mastering these areas is not just beneficial, it's imperative. Let's delve into the importance of user administration and disk management. These components significantly impact both operational efficiency and security. Proper user management prevents unauthorized access and ensures that legitimate users have the necessary rights to perform their tasks effectively, crucial for maintaining the integrity and confidentiality of information. Disk management plays a pivotal role in optimizing system performance. By efficiently managing disk space, administrators can prevent system slowdowns and crashes that occur due to disk space shortages. Additionally, effective disk management strategies are vital in disaster recovery scenarios, ensuring that data is correctly partitioned and backed up. Moreover, in the context of compliance and governance, effective user and disk management ensures adherence to legal and regulatory requirements regarding data access, storage, and security. This not only helps in avoiding legal penalties, but also in building trust with stakeholders by demonstrating a commitment to data security and integrity. Now, let's understand user accounts and user groups. User accounts are the cornerstone of system security and management. They represent an individual's identity on the system and dictate what actions the user can perform. User accounts can be broadly classified into administrative accounts, which have broad system-wide privileges, and regular user accounts, which have more limited access. User groups are collections of user accounts that share common access rights to files, systems, and resources. Managing users in groups simplifies the administration process by allowing permissions to be assigned to multiple users simultaneously. This not only reduces administrative overhead, but also minimizes the chances of errors in permission assignment. For example, in a corporate environment, different departments might have distinct access needs. Setting up user groups such as finance, HR, and tech with specific permissions can streamline process flows and enhance security, as users only access the data necessary for their roles. Finally, let's discuss the role of user privileges and roles in system security. User privileges define what actions a user can perform on a system. These can range from the ability to install software, access certain directories, to configuring system settings. The principle of least privilege suggests that users should be granted only those privileges essential for their work, crucial in minimizing potential security risks. Roles, on the other hand, are sets of privileges grouped together that can be assigned to users or groups. This makes managing privileges more straightforward and more consistent. For instance, a network administrator role might include privileges for managing network settings and hardware, whereas a database manager role includes privileges pertinent to database administration. Applying roles and privileges meticulously is essential for maintaining system integrity. An unauthorized user with excessive privileges can cause significant damage, either accidentally or maliciously. Thus, defining roles according to job functions and applying them appropriately is a critical task in user administration. Section 5. Authentication processes and password policies. Authentication is the process of verifying a user's identity when they attempt to access a system. This usually involves a username and a password, but can also include other methods like biometric data or security tokens. Effective authentication mechanisms are the first line of defense against unauthorized access. Password policies are critical in strengthening authentication processes. These policies dictate the complexity and rotation frequency of passwords. For example, a strong password policy might require passwords to include a mix of uppercase letters, lowercase letters, numbers, and special characters, and to be changed every 90 days. Implementing multi-factor authentication, or MFA, which requires more than one method of verification, significantly enhances security. For instance, after entering a password, a user might also need to provide a fingerprint scan or a code sent to their mobile device. This layered security approach greatly reduces the risk of unauthorized access. Section 6. Overview of disk management. Disk management is an essential aspect of system administration, involving the oversight and configuration of physical and virtual disk drives. This process is vital for ensuring that the storage resources are used efficiently and remain in good health, which directly influences system performance and reliability. The primary tasks in disk management include partitioning drives, formatting them with appropriate file systems, and mounting them to make the storage available to users and applications. Each task is crucial. For instance, improper partitioning can lead to inefficient use of disk space, while incorrect formatting can result in data loss. Moreover, disk management tools allow administrators to monitor disk health, manage disk quotas, and perform defragmentation and cleanup operations. These tools are indispensable in maintaining disk performance and longevity, and in ensuring that data is stored securely and accessibly. Partitioning a disk involves dividing it into isolated sections, each of which can be managed separately. This is beneficial for organizing data by category, improving system performance, and enhancing security by isolating different types of data. For example, system files can be separated from user data or application files, reducing the risk of accidental deletion or corruption. The choice of file system is crucial as it determines how data is stored and retrieved. Different file systems offer various features, such as support for large files, robustness against corruption, and compatibility with different operating systems. Commonly used file systems include NTFS for Windows, ext4 for Linux, and APFS for macOS. Configuring the right file system and partition layout requires careful planning based on the specific needs of the environment. For instance, a database server might benefit from a file system optimized for handling large files, while a general-purpose server might use a more versatile file system that balances performance and data integrity. Formatting is the process of preparing a partition with a file system so that it can store data. This step is crucial as it sets up the underlying structure that manages files and directories on the disk. Different formatting options can be used depending on the intended use of the disk, such as quick formatting for fast setup or full formatting that checks for bad sectors. Mounting a disk makes its storage space available to the system for use. This involves linking the file system on the disk to a directory in the system's file structure. Proper mounting ensures that applications and users can access and store data efficiently. It is also possible to mount network drives, allowing for shared storage across multiple systems. Automation of these processes through scripting or management software can significantly reduce the workload on system administrators and minimize human error. For example, scripts can be programmed to perform routine formatting and mounting tasks during off-peak hours, ensuring that the system operates smoothly with minimal downtime. Disk quotas are a tool used by system administrators to control the amount of disk space that can be used by a particular user or group. This helps prevent any single user from consuming excessive disk space, which can affect system performance and availability of resources to other users. Setting up disk quotas involves specifying limits on the amount of data that users can store in certain directories. This can be particularly useful in environments where disk space is at a premium, such as in shared hosting scenarios, or in organizations with large numbers of users. Monitoring and enforcing disk quotas require diligence and regular checks. Administrators can use tools that alert them when users are nearing their quota limits, thus enabling proactive management of resources before shortages occur. This ensures a fair allocation of storage resources and maintains system efficiency and user satisfaction. Effective management of user administration and disk management is fundamental in ensuring a secure and efficient computing environment. By implementing best practices in these areas, administrators can safeguard sensitive data, optimize resource use, and maintain high system performance. This not only enhances productivity, but also fortifies the system against potential security threats. The skills required in these domains are multifaceted, involving a mix of technical knowledge and strategic planning. System administrators must continuously update their understanding and methodologies to tackle emerging challenges in modern IT environments. In this endeavor, the deployment of advanced tools and adherence to best practices play pivotal roles. Ultimately, the mastery of user administration and disk management is not merely a technical necessity, but a strategic asset. Organizations that excel in these areas gain a significant competitive advantage by ensuring uninterrupted operations and robust security, thereby fostering trust and confidence among users and stakeholders.